These are the stages of a simulation project, which are similar to any kind of project. So first you need to define what your system is and what your objectives are. And they are very interrelated because depending on your objectives, you will take into account some part of the system or not. Imagine you want to explore how the congestion of a railway system is during part of your day. So some stations might be relevant for you to account for that congestion, and some other stations are not. So you might not need to represent them all, and you can leave some out of your model because you can model them in a more less detailed way. Second, you need to build a conceptual model, which is the way to refer to the set of assumptions regarding how your system will be modeled. So, for example, you might imagine again in a railways a system where you're evaluating how vehicles should move. You can make two assumptions like trains move at an average speed, or you can do an assumption by means of which you need to compute the acceleration, the speed at every time, and how the speed varies over time. Depending on where you're modeling, you might need to represent the speed in a more detailed way or not. Third, you need to create a communicative model, which is the way for everyone in the project to understand each other. So people are not experts in simulation, and analysts in simulation are not experts in the system. So you need to create a document, which is the one that gathers all the requirements, which is the document everybody in the project will refer to make sure that things are done according to the conceptual model and to achieve the objectives for the system and the problem addressed. Fourth, you start with a software model, which is the part where you create using the language you want to use something that translates everything done so far into something that you can run on a computer and get results. When you have that, you have something that you can use, you can experiment, you can explore different configurations, and out of that, what you get is a solution that you implement in a documentation both for the model in case you want to reuse it and someone else is going to extend it later on. You want to give him or her good material to be able to extend the model, and the documentation for the solution you have decided to implement. And there are three major concepts here in this process. One is validation, which is the process or the everything related to having a model that reflects how the real world is. So it's very present here when you're making assumptions about how your model will be. You should validate those assumptions. You need to talk to experts, you need to do some numbers to make sure that you're making the right assumptions. At the end of these stages, you also have to validate because once you have this model, you can extract numbers. So if you have a model and use as input information what happened in the past, you will get output information that will or should resemble the output information you had in your real world system. And that allows you to validate. So to make sure that you're representing with enough validity your system. Here, what you have is the verification, which is the step by means of which what you do is you make sure that everything is programmed, is coded the right way. So you have an assumption, a set of assumptions, and you make sure that all these assumptions here are well translated into a program that does what it's supposed to do. So for a model to be valid, it should be verified. But you might have a model that is well verified, that is well programmed, that the code is very clean and very reusable. But if the assumptions are not good, you'll have a verified model that is not valid. And finally, after all the process has finished, you can check the credibility, although you can take care of it all along the process, which is the fact that results are something that managers will rely on and will make decisions based upon it. This is something that might seem very obvious, but it is not. You can have a very good model, a very valid and very well verified model, but if the top management does not think it's a good model, it won't be used and it'll be a waste of time and money. At the core of the simulation project is the software model, and I recommend you check some modules, some lab modules by Jeff Smith, for example, to explore and to get introduced to software such as say Simio. Or I have my own tutorial myself, which is a shorter one, but it doesn't cover all the topics that Jeff Smith covers. I think that is a very good introduction for you to get started with Simio.